Transition elements have very strong metallic character. This is because of greater effective nuclear charge and a large number of valence electrons. As metallic bonding is very strong in transition elements are very hard and have high densities. Again, they have very high melting points and boiling points. This is because of very strong interparticle bonding. Besides metallic bonding, in between the atoms of transition elements, there may also be some covalent bonds present because there are half-filled or incompletely filled d orbitals. This results in very strong bonding, and transition elements have thus high boiling point and melting point. Ionization energies. Transition elements have ionization energies which are higher than those of s block elements but lower than that of p block elements. This transition is found because as transition elements have their orbitals filled, there is an increase in the nuclear charge. But again, as the electrons are filling the inner n-1d orbital, the increase in the nuclear charge is nullified by the increased screening effect. Thus, the increase in the ionization energy along the d block elements is very small. Atomic and ionic radii. Transition elements are found to have atomic and ionic radii smaller than that of the s block elements. This decrease in size is due to the increased nuclear charge. Again, along the period of d block elements, it is found that the atomic radius decreases till the middle and then increases towards the end. This is because as the nuclear charge is increasing, the screening effect is also increasing, and thus the two effects balance each other and the radius therefore remains constant, or we can say even decreases from in the first 5 transition elements. After the d5 and the d6 are filled in, there is a pairing of electrons taking place. This pairing results in greater repulsion between the electrons, leading to a expansion in the electron cloud, and thus the atomic radius increases towards the end of this period of d block elements. Oxidation states. Transition elements all show variable valency except zinc, cadmium and mercury. This is because zinc, cadmium and mercury have got completely filled d orbitals. Now coming to why other transition elements show variable valency, it is because of the participation of the ns electrons and the n-1d electrons in bonding. When the ns electrons are participating in bonding, the metal shows the lower oxidation state, and when the n-1d electrons also participate, then the metal shows the higher oxidation state. The transition elements in oxidation state 2 and 3 generally form ionic bonds. When higher oxidation states are exhibited, then these metals tend to form covalent bonds. The highest possible valency or the highest oxidation state a transition element can show is 8. Transition metals form complexes. Complex formation by transition metals is primarily due to 2 reasons. First, because of the small size and the high charge density of the ions of these transition metals. The second reason is that these transition elements have got vacant d orbitals which can accommodate electrons from the donor ligand with which it can form complexes. Colored salts. The compounds of transition elements are colored both in the solid state as well as in aqueous solution. This can be explained on the basis of the unpaired electrons in the d orbitals. All the d orbitals do not have the same energy content, especially in the presence of the attacking ligands. They break up into different orbitals of slightly different energy levels. When the d orbitals are partly filled, electron jumps or transitions can take place from the lower energy d orbitals to the higher energy d orbitals. This results in the absorption of a small amount of energy which falls within the visible part of the spectrum. When light of a particular wavelength is absorbed, the emitted light will be of the color complementary to that what is absorbed. Hence, complex salts or compounds of transition metals are colored. Again, zinc salts we know are not colored. This is because zinc has got a completely filled d orbital. Therefore, orbital to orbital transition is not possible. Hence, zinc salts will all be white. Magnetic character. The transition metal ions generally contain one or more unpaired electrons in their d orbitals, and hence they show paramagnetic character.